The magnetic field around a compass isn't just a two-dimensional thing, it's actually three-dimensional. And you can probably just about see that the iron filings in this oil are suspended and going around in field line patterns in a three-dimensional shape. So they're sticking out from one pole and from this pole, and they look as though they're going to link between the two poles. So I've shaken it up a little bit, and what you can see is the iron filings drifting around inside the oil, but there's definitely a pattern where they're trying to link from the North Pole inside the magnet here to the South Pole. And in fact you can see them stretching across in a kind of three-dimensional shape around the magnet. The Earth has a magnetic field around it, as you're aware, so it has a north and a south pole, and we can show that with this compass here. So you can see that the compass needle follows around the magnetic poles from north to south. Interestingly, obviously we always take magnetic fields to go from north to south, so a plotting compass like this one will always point from a north to a south pole, so it will always go towards the south pole. So in fact the Earth's north pole is actually down here, because the plotting compass will always point towards the south. It follows the field lines. So in the north of the world is the magnetic south pole, and in the south of the world, down in the Antarctic, is the magnetic north pole. So the magnetic field goes from north to south, and a plotting compass will always point towards the south pole.